In today's lesson 10.1, the circle, we'll be reviewing lots of things that have to do with definitions of the circle and theorems about the circle. The first definitions that we're going to talk about are circle, radius, and the center. What a center is, or what a circle is, it's a set of all points in a plane that are given distance from a given point in the plane. So basically, you have a given point, and that given point will be the center. And the circle is composed of all the points that are equidistant from the center. And the points around are the ones that compose the circle. What the radius is, it's a given distance from the center to the outside. So this would be the radius. And again, remember, it's always equidistant. If I have multiple of these lines, again, it is called a radii. That's the plural form of radius. The next definition is concentric. What concentric is if you have two circles that share the exact same center. Now, they do not have the same radius, but again, the centers are shared. So they're kind of within a circle within a circle. We can define two circles to be congruent if they have the same radii. So if I have a circle, if I have a circle here that has a radii of 5, and I know a circle over here also has a radii of 5, then we can say that the two circles are congruent. To have an interior point of a circle, the point has to be less than the radius and obviously lie inside. So a point here or here, let's call these A and B, those would be interior. While an exterior would obviously be on the outside of the circle past the radii. And if it's on the circle, it would have the same distance as the radii, so that would be something like D or E or F. The next definition is a chord. A chord extends and it connects one point that is on a circle to another point that is on a circle. So EF is a chord, as in FE. And the longest chord is considered the diameter. The diameter goes from one side of a circle to another that passes through the center. Now we'll talk about some theorems having to do with chords and radiuses of circles, or radii of a circle. Theorem 74 states, if a radius is perpendicular to a chord, then it bisects the chord. So in this case, if we see that in circle A, the radius is AB and the chord is CD, and if we're given that AB is perpendicular to CD, then we automatically can conclude that CD is bisected by AB, and that CE is congruent to DE. In theorem 75, the opposite is true. If a radius of a circle bisects a chord that is not a diameter, then it is perpendicular to that chord. So in this case, again, given a circle A and chord CD, and that AB is the radius, if we know that CE is congruent to DE, then that automatically tells us that AB will be perpendicular to CD. If we're given the setup as the following, that CD is a chord, but we know that FD or FB is a perpendicular bisector to CD, then we automatically know or can conclude that BF, if extended, that line will pass through the center.